Would you say then, off the back of that, device management truly should be at the forefront of the minds of the teams that are in charge of deploying the said systems, as opposed to, say, connectivity as a forefront thought?
Yeah, so device management is a very wide topic. So I think AI device management as a narrower field, as I alluded to earlier, being able to routinely update your models, whether they're Zoom models or not, is a useful feature to do that. Making sure that you have some way of validating prediction on a device when it's doing inference as well is useful. And so quite often you're trying to predict the future with these things. So there might be some supervisory reinforcement data that's available on the device knows about, but maybe not at the time it's doing that first inference.
Hello, and welcome back to another episode of Making It Happen by Sims. My name is Alex, and I'll be your host for today. If you've been following Sims as of late, you would have seen that we've been taking a deeper dive into the world of Edge AI. And today I'm joined by someone who really knows that space inside and out. Pierre Drezet from INX Limited. Pierre, it's great to have you with us on the pod today. How's it going?
Good, thanks. Bit of sunshine in the air today as well. So lovely to be here.
It's always nice. It always keeps things positive when the sun's out, for sure.
Yeah.
So, Pierre, we spoke initially at TechX Global back in February. Now, obviously, it was a great event. We touched on many topics regarding Edge AI, integration, deployment of different systems, and we will get into all that. But first, what would be great would be if you would be kind enough to give us a little bit of information regarding your technical background, INX, and the work that you guys do.
Yeah, I'll start with myself. Not always my favorite subject, but so I'm a systems engineer. I did my degree in systems engineering in the 90s, and at that time, machine learning was having one of its sort of resurgences after a few full starts in the 80s. So it wasn't quite that long ago. And so I worked on machine learning when it was all really done and expected to be done at the edge. There was a cloud at that point, but really the applications were more hard-nosed, medical, those kind of things where they tended to be expected to be better than humans rather than scaling more media-friendly applications since then. So yeah, I learned a lot about the fundamentals. I learned all about how you can deploy on constrained devices, and also a lot of those use case and product management things which are evolved. And so yeah, moving on to what we did with INX, which was an evolution of how to deploy technologies like that. And we kind of got into Internet of Things. We built an Internet of Things platform by accident because we had some clients who wanted a connected service building for them. So we built a platform that, and we coincided with also making no-code software for embedded devices. So that was some more than 10 years ago now. And we've been doing IoT ever since then. And I think Edge AI and IoT are very similar. You don't really have many Edge AI applications without an IoT aspect to that as well. So quite a broad knowledge across the whole deployment, the life cycle of products and services. So INX, our core, we've done a lot of IoT, but actually our core product is mentioned no code environment, which is really about systems integration. It's not as much about developing applications. It's about doing that systems integration work ahead of when you're building your applications. And that works very well for Edge AI and IoT. The deployment costs and integration costs are the most significant part of the NRE for these kinds of projects. So we do that with technology rather than services.
Fantastic. No, brilliant. Thank you for that. So we've mentioned edge AI integration. And I know in past we've spoken about the responsibilities associated with such a goal and where ownership of certain areas of that process may sit. Now, it'd be good to get your thoughts to start us off in terms of where you think ultimately that responsibility lies for each different section of that integration process. And, if, during that stage, if there's any sort of trademark cracks that potentially seem to appear if a certain area of the ownership hasn't fully been taken on board or maybe isn't done in an assertive manner, for example.
Yeah, and there's a number of patterns.
Mm.
There's some that work and many that don't. But there are different situations. So I think the conversation we had before, you tend to sort of split that integration into two types, which are fundamentally different approaches. So one is when you're doing that integration in situ, which you get a lot in industrial applications. So you need to make a product that is not only integrated within its device itself, but you also need to be able to integrate with a broader set of other peripherals or components or network and data connectivity and those kind of things. And then the second class is more the OEM play where you're doing that systems integration in device. They tend to be deployed more homogeneously, so they don't need as much of that in situ or any depending. A consumer product has to be designed such that it can be installed with minimal aspects, unless it's a fixture that an installer's using. So there's a bunch of patterns that you have to kind of recognize which ones you're in, and once you do that, there's a various ways that you can go about solving that. But quite often it does get left to serendipity, and somebody may be left with holding a baby who wasn't expecting that. So we've been through some of those routes previously as well.
In terms of when you're sort of, as you say, left in that situation, what, from your experience, was the key thing to sort of get resolved in order to put that into a more sort of productive stage, as opposed to just being left there, with your hands in your pockets, wondering, who's going to pick this up? What would you say from your previous experiences? And it'd be great to get, any examples that you're sort of happy to provide us in terms of, actually that was the shift in the moment, which we said, okay, yeah, this needs to be done as soon as possible, and then that's going to get us from X to Y.
Yeah, I mean, so one advantage you have if you do IoT and you make sure you have certain things in place like over-the-air updates is you can defer some of that. So customers, especially startup customers who've got an innovation, they tend to want to get it into the market quickly, and they tend to want to kind of not have everything right, and that's something you have to live with. Those kind of customers aren't going to be spending 2 years developing something, or they may not be planning to spend 2 years developing something before they deploy it. They're planning to deploy quickly and test the market. So you have an advantage there that as long as you have a certain few things in place, you can actually build out that product management part that didn't get done earlier. You can deliver some of that over the air. So, for example, when you have an installation that often needs a network connectivity, and somebody has an issue with the network, you're often the one who's going to be asked. You're the one who can see whether this thing's plugged in or not, rather than sending a van out. So we have SLAs with our customers to say, here's a triage process. Before you call us, we're happy to kind of do the backline stuff, or sometimes more in the foreground. So having an SLA in place to say, like, this is what we can do to help you resolve those kind of issues. So these are kind of these in situ integration type of problems you might get. Often networking, sometimes in Edge AI. We have projects which have had a lot of generative work going on in them, and luckily that bit has been done relatively well. But one of the things about generative AI, and especially machine learning based model AI, is that it's been developed to date largely with humans in the loop. So they're not designed for working forever unattended all the time, and you have to kind of put certain things in place to make sure that when something's not working as expected, you have that diagnostics, that remote diagnostics there to say, well, that's because of this, that, and the other. That can be very business logic level, or it can be even sometimes just having good login of the right things on your device, so you can see what's actually happening. So you do have to work as as a R&D end, so you're doing the product development with your customer. You are likely to be involved in that operational side for a little while. When you're talking to bigger customers or customers further down that stage, and they're doing their wider scalable version, you tend to just make sure you've designed all of that stuff to be solid. You still need those diagnostics. You still need over-the-air updates, security patches, all of that. But it's not something that we will be getting involved with as much. But those first 6 months of a project, you have to be prepared to get calls, basically, because you're the one who can help most easily.
Yes, and I remember from our chat back at TechX, there was the phrase that we sort of used where the AI applications or platforms at this current stage in time are only as effective as the individual that's training them and the extent to which they've been trained at this stage anyway.
Yes, yeah, and I mean, another. I like to kind of split problems into two different versions of that problem. So you've got the model zoo approach. That's a lot easier. You tend to be people who've trained those and they've been tested by a wider class of people. They're not going to necessarily be optimal, and they may not even be capable of doing what you need. And then you do need to do your own training. So vision systems is the one which is most intuitive for people to do themselves. So there's a whole bunch of tools around. So there's a skill side to it and there's a tool side to it, I suppose. The skill side is that you need to kind of train your models in all those cases that it's going to see in real life, and that's surprisingly difficult. Things do drift. In vision, lighting systems change. The objects themselves may be varying, and annotating data is often manual. So you don't want to be repeating that frequently. So some good tools that are available will let you acquire data from the device to do more training, but that can be a problem if you've got limited bandwidth, which a lot of edge AI claims are to reduce bandwidth and reduce data being distributed more broadly than it needs to be. So it does depend a lot in industrial situations. A lot of people can do that on premises, but then those tools are normally cloud-based. Not always, but often cloud-based and not so easy to work with. So yeah, you are going to be having to have your kind of R&D engineers involved perhaps longer than you might expect. There's very few projects that aren't in very kind of specific environments that don't need some ability to maintain the models, and trying to avoid conflating updating the models with the whole software stack, which is often another problem you'll find with the tooling. That's something that we are particularly keen to untangle for customers, because there are many risks of doing software updates that there aren't with a model update.
Yes, of course. In terms of, we spoke about R&D side of things there, and I sort of want to bring it back to the thought of where you have the testing conditions that take place within the lab, and then you've almost got this kind of stark contrast when certain solutions are deployed in the field. Why is it that you think that sometimes a solution or a system that operates, well within its expected capabilities in the lab setting won't always directly translate that level of performance to when it's deployed in the field in a live situation?
I mean, it is a different environment. So the classic issue with machine learning is overtraining on a training set or on a validation set even, and then you go into a statistically different environment in real life. Now, vision systems are particularly sensitive to this. If you're doing things like time series and voice, it's a bit less of an issue. But yeah, so So the options you've got to kind of generalize is you have lots and lots of data, but you have to make sure you choose lots and lots of data. There's no point having lots of data that's the same. You need to have it distributed. You also need to make sure that it's distributed in such a way that it's the frequency of seeing these kind of unusual cases is not going to overwhelm the normal cases, because you tend to overgeneralize to some degree as well. So it's the classic balance of being able to balance three things. One is your data actually representative of real life? And that can be impossible in some cases. Um, Different weather conditions, how are you going to actually gather data? There's ways of generating data and simulating those, which can be used. But you're talking about quite big projects that don't tend to be done frequently, routinely by in situ engineers who are kind of doing that day to day. So there is a lot of maintenance to make it work, and the drift problem for most machine learning happens a lot. So condition monitoring for things like that case of time series monitoring. Your model might still be fine for when that device was new, but it's now 3 years old and it's rattling, but actually everyone's fine with that. You're not going to go and replace it just because it's rattling a little bit more. And you need to be able to adapt to that. And that's one of the challenges in machine learning right now is doing learning on the device. Not something that many people are trying to ship, but especially in that time series kind of cases, adaptive learning is doable, but it's not off the shelf right now. But that can solve a lot of that maintenance, human in the loop maintenance issues for you as well.
Would you say then, off the back of that, that device management truly should be at the forefront of the minds of the teams that are in charge of deploying the set systems, as opposed to, say, connectivity as a forefront thought?
Yeah, so device management is a very wide topic. So I think AI device management as a narrower field, as I alluded to earlier, being able to routinely update your models, whether they're Zoom models or not, is a useful feature to do that. Making sure that you have some way of validating prediction on a device when it's doing inference as well is useful. And so quite often you're trying to predict the future with these things. So there might be some supervisory reinforcement data that's available on the device knows about, but maybe not at the time it's doing that first inference. So a lot of time series is actually predicting the future. You find out whether you were right or wrong quite soon, and you get your real kind of error rates at that point. Object detection, stuff like that, that tends to be something that a human is probably going to be saying, okay, this device is got a bit of a thumbs down at the moment on this battery line or whatever it is. It's not performing, and that just needs flagging. And you don't want somebody to be ringing up and trying to describe that problem to you. You probably want to be able to just have a look at the actual data. So what kind of statistics is it doing? What probability thresholds have you got? What are the receiver operator characteristics you can glean from doing that? So there's a whole bunch of statistics that you should be reporting back regularly in a device management standard part of that. Leaving these things and forgetting them and hoping they work for a long time isn't going to cut it most of the time.
Yeah, it doesn't sound like the best plan, to be honest. So.
No. Yeah. I mean, it's very domain specific how you can validate what a device is doing, but worst cases, and in many cases, it's quite a reasonable way to do it, is there'll be some kind of user interface on the device that somebody, an operator, for example, can give some reinforcement. This is doing well, not doing so well. Otherwise, you hear it back from the business managers, and things can get a bit sour at that point. But if you build that in as an expectation to start with, then generally people are happier.
Yeah, it's almost as if a work in progress. Obviously, it's like a constant role that you have to play, as opposed to, as you say, leaving it once and then hoping it will be fine. then a couple of weeks down the line, months down the line, something starts rattling, all the data that's coming back starts to not correlate with what you initially wanted, to see from that perspective. Obviously, as you say, questions are going to be asked, and the ownership, and it comes back to that theme of ownership and responsibility to an extent. Has to really, it takes the right individual, the right team to step forward and say, yeah, we're owning this, and we're going to take it by the horns and make sure it operates in the correct way.
Yeah, absolutely. And medical applications typically is a human around who's going to kind of filter that output of an AI as well. And I mean, there are some subtle dangers. Things can drift subtly that humans don't notice, and it's very hard to measure success rates without doing quite a lot of big data in parallel. So that's probably more for the medical automotive self-driving cars, perhaps to a point, but there's not many people making those models right now.
I've seen some of the videos of like the test runs of these, and it's all fantastic when they're moving within a very small space. But obviously, naturally, the begs question of when they're deployed in a real field scenario. I mean, there has to be such a high stringent level of testing that has to be undertaken before anything of that variety of technology can be released in a true live field scenario. I mean, obviously, there'll have to be a certain element of control in place right up until the end, right? In my opinion.
Yeah. I mean, especially outside on roads with weather. Who knows if you have covered all of those cases? The type of machine learning that's been used, which is most scalable, it's not well known for generalizing well. You have to teach it how to generalize more than it just does that sensibly for yourself. So yeah. It will extrapolate in very bad ways, potentially in things like bad weather, and there's very little. So I think one of the arguments in self-driving vehicles is whether you need to use other non-vision methods of adding to that sense of fusion, if you like. So I know one school of thought was that it can make it worse. Others, I think that's reverted a little bit now, that it just, if you do it properly, it makes it better. But importantly, it can tell you when you are outliers. That feedback, you've got a method of saying, look, this device is now not doing the same kind of statistics as it was before, because we're getting diverging results from two different independent sensor types. So any opportunity you've got in even a simpler thing like an industrial quality control system, if you've got something else that you can use to just corroborate that, there's generally an opportunity you can do that quite easily, and adding that into the device, into the product, or just as a business process. It's not much different to having a human on a factory floor sometimes, that they all need to be kind of checked that things aren't drifting, because different staff, different times of day, things vary a lot. You obviously can solve a lot of that with machines, but they still are vulnerable to a little bit of more systematic drift in these things.
Yeah. I'd like to talk a little bit about budgets in terms of allocation for projects such as these, especially the larger scale projects that we've seen and sort of will be in place at the moment regarding Edge AI. Obviously, when we first spoke, we spoke about the sort of clear cut line between R&D and operational budgets, and that we lightly touched on the changes that happen when that switch is made from R&D to operational. In terms of taking that step from the R&D side of things to the fully operational budget side, what in your experience would you say is sort of either the pattern, I know we've spoken about patterns a lot this afternoon, or the sort of tipping point in which, for example, high capex, or what is deemed to be sufficiently high capex, is tolerated early on in the R&D phase, but then when that switch is made, attitudes can sometimes change to allocation of capital, and what you think that could look like moving forward as companies continue to take on more projects revolving Edge AI?
Yeah, it's a good question, and so lots of facets to answer that, I think. I mean, I suppose the most general thing is it's in any kind of electronic system, it's typically easier to get to a functional system with an over-specified system first, and then reduce that later. And a lot of people don't really plan that properly, and they'll make prototypes which are kind of in between. So it'll be something that's going to please the investor or the CFO of a company. They want to see something tangible, but often that can be just the worst of both worlds, where you've got a prototype which was actually looks too good, but doesn't actually do the real performance you need, and that might be operating costs as well. So there is that kind of planning in a migration from the right kind of prototypes, the right kind of MVPs, to ones which are going to scale, and making sure you haven't denied yourself a roadmap to something scalable, because companies do often flatline because their product's too expensive to either sell or operate. And companies do tolerate that for quite a long time if they're well invested in it. But they very rarely, if they haven't planned it, they very rarely will do that again, because it still costs quite a lot to do it again, especially if you're switching hardware platforms. Something our product is very good at. Smoothing the way for, but in general, you're going to have to make another model at least. That's something we're not solving, but you won't have to rewrite your application in C++ from Python, for example, and those kind of things. So there's an art to that, and most people know that there's a possibility that you might have to cost optimize, but they don't really plan for it properly. And they do ship the prototype, and it does cause a lot of friction. So yeah, I mean, I was thinking of another sort of facet to that answer that question. So yeah, can you repeat the question actually? Because it did spring something else which I've now forgotten.
No, sure.
It's been a long day.
No, I appreciate it. So no, yeah. So I think you've covered the first points quite well there, but the second point of the question was, there is obviously the incredibly high capex toleration for the R&D budgets that isn't always reflected when that switch is made to the operational side. And just to make it a little bit more sort of complicated, I'll throw in an additional sort of caveat to that as well. When the companies are in the R&D phase, if they're, say, for example, you mentioned performance there, sending a prototype that might not quite be hitting those benchmarks just a tad, where they should be hitting when the prototype is first sent. Is that because the teams are more willing to sort of sacrifice that element of performance for potentially an element of the life cycle or the reliability of the project moving forward, where they think a drop of performance early doors, they can actually accept that they've got the sort of ability to tolerate that more than when they get to the operational side of things? Is that how it tends to go?
Yeah, and you should definitely plan to do that. It's just something you need to make sure that goes ahead, and you have that. It's just very hard to let go. It's the sunk cost fallacy if you haven't planned for that. And it's an adage of any software project is make sure you throw away the prototype, because when you don't, you tend to suffer long term. That's been the same since 1973 or whatever, whenever that book was written. So it's that part hasn't changed. That's just a human condition of engineering. But yeah, no, I think the other side to that question is with Edge AI. It's kind of new, and it becomes the central thing that people want to prove in the demo, in the proofs of concept. It's all about the AI. Most products that are actually going to save people money, or make something better, need a lot more than just that to work. So if it is acting on its outcome, the difference between showing an object detection system drawing boxes around people on the screen, which is what you get off the shelf from any number of machine vision companies and products, changing that into something which actually has that whole, well, I need to do something about this now in situ autonomously. That's why you're going for Edge AI. It's not just to draw boxes on the screen for somebody most of the time. It's going
Mm.
to be uh, no human in the loop control of some kind, or at least supervision, perhaps monitoring without lots of false positives and those kind of things. So you have to kind of think about that whole product. You have to think about its IoT, its security, its local user interface, and those kind of things. And those tend to be left till the end, and then they become too difficult to deploy because you need an R&D engineer to hold somebody's hand to use it. Because you just haven't thought about all those other usability aspects of that device, because it's been so interesting to see it do something magical with with its machine learning model or something like that.
Yeah, it's a great point. I think it's also one of the reasons why a fully integrated vertical system, when it comes to edge AI deployment and system use, is so important. I think that when you talk about the object detection, for example, having that fully integrated system to back up the data that that machine is gathering, and the objects that are actually being detected there, the MIPI camera systems, potentially a Ethernet cable deck as well, if you're going to be, say, using an edge AI system and then running up to, say, 10 MLPI cameras off of it at once for different
Mm,
detections from different angles, different distances, different shapes, etc. It's a great point to make about the integrated systems. And we at Sims have recently partnered with Inadisk and Athena
mm,
to help with sort of the hardware aspect of relationships based here in the UK and Europe. So the fully integrated systems that we're offering from Inadisk, obviously they're powered by a mix of NVIDIA, Qualcomm, and Intel processors. And
yeah.
that has really been a key sort of learning curve for us as a business, obviously being new to this whole world of edge AI that seems to be expanding by the minute. Is that it's
Mm,
about, as you say, the system behind it. It's not just the one box, the one system that's being deployed on site. You have the entire backup behind it, and the work and methodologies behind the scenes that have been rigorously tested throughout months of lab work before being deployed in the field. That it's so key, I think, to successful deployment of these
yes.
things.
Yeah. And having companies that have deployed that same technology broadly
Mm.
really does help you avoid getting stuck with glitchy systems and those kind of things.
Mm. Mm.
Um, but yeah, those it's important that there's also a excuse me there's also a good roadmap for integration.
Mm.
And again, going back to that very first split in what kind of integration we're talking about, those
Mm.
in situ ones, you kind of need lots of different skills as a to do that with services. So some of that might be the actual technical integration, but there's often a lot of product management side of those skills as well. So what platform are you going to do for that application that isn't provided by the vision system company? And so you had some visibility of what's in a Distuna, and they're very open about that, and about how it needs other things. So one extreme is you're going full open source. You're not really using any of these things. Those can be brave projects, but they're also
Mm.
improving, and there's certainly a lot of that in the more uh, kind of run-of-the-mill tech you need for IoT. The IoT tech now is in open source land is basically now the de facto standard. It's stable. It hasn't been stable for that long on all kinds of devices, but it is quite a commodity type of technology now, and it's important to uh, give yourself the ability to use that
Mm.
rather than I use an analogy of carpeting a room with lots of rugs, which are not quite big enough, but too big to not overlap. So
Mm.
you don't want to build products which have a lot of things cobbled together with lots of different platforms that may may not work brilliantly together. So mixing those kind of the hard tech like the vision systems with the the commodity tech, the open source, is a really good way of making yourself fit around the value of your product. So if you've got a USP of doing something particularly well in vision, so some kind of anomaly detection or whatever it is, or you specialized in a particular thing, that's kind of your business moat. You don't want a lot of integration to become your business moat, because that's probably just going to become a burden quite quickly. So you want to be able to have quite a lot of control over that without the burden of having to develop it all. So yeah, I'll try and evolve that big rug story into maybe an infographic one day, but it might not make that much sense right now.
I'd
But
love
it's yeah.
I'd love to see it when it's done.
I can do anything now with AI, can't I? So it might come.
Fantastic. Talking of um, the sort of successful deployment, and that's moving away from the integration side of things and looking more from like a business level. What key signs would you say indicate to yourself that a business may be ready to invest in an edge AI platform, or at least if they've been toying with the idea of full-on scale deployment? What would you say is a sign that a company is ready and sort of mature enough to take that next step?
Um, I mean, I think you've got some which kind of know that it's a low technical risk, if you like. So they know there's a vision system that will do what they need. They just need to apply it to their case. That's quite low technical risk. It should be relatively straightforward to do that. And and some industries are very conservative with things like that. So if they're willing, um, and um, and they know that they've got something which is already maybe done in different parts, which needs to be combined in their way, then that's normally a good sign that they aren't just saying, "Can I have some AI?" They're saying, like, I can solve this problem because I know somebody else is solving a similar problem. So that's somebody who's got that ability. Because what you don't want to do is get into projects where you're pushing AI at a customer all the time,
Mm.
because if they don't pull it in as well, it has all kinds of reasons why that project's not going to run for long. So installers often have a lot of buying decision next time that company wants to do something. If an installer said it was a nuisance or somebody hasn't supported it, and we've just been given stuff from another company that don't really understand our domain, they're going to be quite big objections to going forwards later. Um, on the other hand, there's another sort of ICP is a company that has a lot of data that they know um, could be automated, and they do already do the statistics on it, so they already know that there's a lot of value in that, and that's where the kind of the higher value projects come in, where um, they will typically want to uh, expend quite a lot of R&D on that, and then normally because they know they have got an operational um, uh, effect that they're looking for. Um, and so those are good companies to work with, and especially for Edge AI, because some companies will go down I'm just going to go to my nearest cloud provider, um, and I'm going to make quite a over-engineered, expensive to operate version of what I need. If they go to an Edge AI company, they're more likely to provide something that's going to be quite cheap to run. Not
Mm.
necessarily cheaper to develop, but
Mm.
sometimes, there's certainly a case for. I mean, things are changing. All the cost of making models now is much less. The tools for doing that yourself are as easy as doing that on the cloud. So there's a lot of opportunity to make that NRE part not dissimilar
Mm.
to a cloud-based one, but making the deployment mode have all those Edge AI benefits of operational efficiency and data privacy and reliability as well.
Mm.
So yeah, that's something I think is a good door to kind of push a bit harder on when you have customers that kind of have that scale of deployment, and they know they've got a lot of data that they can save money with. Because companies do never get out of that R&D budget, and they will just break even on operating costs with some of those, because large data sets normally mean at deployment there's a lot of data being involved as well, and sending that over to the cloud for every frame can be quite an expensive business. So those are a good ICP for an edge AI advocate.
I mean, I think we could speak on the topic of cloud versus edge AI. I think that's a whole separate podcast in itself, to be completely honest with you. But of course, but I think that cost, as you say, obviously is an important factor to note. I think as well, the sort of utilization of OBB on certain edge AI devices as well, compared to the requirements for, say, for example, a network engineer to be called in for a resolution of a cloud issue, for example, if there's a cloud outage or a sort of relevant network or server issue. I think from the conversations we've had, within the space, early days, that's been one of the sort of most commonly sort of mentioned themes. I'm not sure if it's something that you've seen a lot on your side.
Yeah, I mean, we've always had a policy of things work when they're disconnected, and as degraded or undegraded as possible. So yeah, I mean, it's one of those things that especially, so vision's an interesting one in that it's quite cheap to send vision data around a local network. It's compressed. It doesn't clog up most networks, but sending that to the cloud for function, is dangerous ground. Not just because of the quantity of it, but if these things are valuable, they tend to need to work all the time. If it stops for a day, and this does happen quite frequently with some projects we're aware of, that can mean somebody stopped work, maybe a highly paid professional has had to stop work for a day or do something else, or have to go and do that work themselves. But normally those systems are now preventing them working in the way they used to, because there won't be a manual mode for those. So it's another product management skill, if you like, is what if it's disconnected? What's it going to do in those cases? So those easy wins of getting your Raspberry Pi and streaming data from a camera and then sending that back out to the cloud for processing, that's a quick way of proving something to an investor potentially. So going back to that, where do you split the proof of concept and then excuse me, and the MVP? That's fine, show that you can run this algorithm on the cloud in Python, because that's the best way to kind of do that, and it's the cheapest way of doing that. But if you then go and deploy that product, excuse me, you're going to upset your customers pretty quickly when it goes glitchy, which it will do. So yeah, there's definitely a disconnected mode that every product we've worked on, and to be fair, when we've done projects with other customers that are doing big deployments, that's in their kind of top 5 features of disconnected mode.
Right, brilliant. If you could change one thing yourself about how companies generally approach the integration of edge AI systems and how they go about developing and then fully deploying their chosen systems, what would you choose? I mean, in terms of if you were, say, given, right, Pierre, you have the ability to go out there and speak to X amount of companies, and you're going to tell them exactly how you think they should maybe change an area of their operations, or a way in which you feel that they could be doing a certain process or completing a certain area more efficiently or differently. What would you say is the number one thing that you would change?
Okay, so this is the application, not the tech. I think is that the question?
Yes, correct. Yes.
Well, so I think Yeah, I mean, the the actual AI part is rarely the problem. It's the IoT parts of these things is have you thought about how this actually works? Because you're kind of embracing a lot more than just an automatic system. You're embracing a kind of tech that you don't know how to handle.
Mm,
And I think this is
mm,
another one of these cost operations questions in a way is have you actually thought about this other than as a whole set of features that you need and you can build into your operations? Because if you build this in a siloed, it just does something clever, but it's not integrated well with your business. It will kind of wither away, and if it's a nuisance, if it's more of a nuisance than it fixes, then it will weather away. It won't get recommended next time, and it's easy to get a bad rep with those kind of automated systems. People aren't en masse going, I want to go and find an AI system. They want to go and find something that works, and AI can make that work better. So I think, yeah, boiling it down to one thing, I'd say don't think about the AI as the solution. Think about the AI as part of the solution, and decide what you want to do from that perspective.
mm. Yeah, fantastic. I think, yeah, it's an excellent point to make. I think that as well, as you say, it's not the end solution. In many cases, it's actually the implementation of the AI that's actually going to contribute to a wider system and therefore then
Yeah,
deliver the solution the way in which the business in mind needs it to deliver, which I think is very important to remember. Um,
yeah. People buy products and services. The AI is just a way of doing that, and if you do it the other way around, it causes all kind of misunderstandings, uh, and and cost misappropriation as well.
And it comes back again. It comes back to that question of ownership and integration, doesn't it?
Yeah,
Really, it
absolutely.
all comes quite nicely full circle if the integration is fully managed. Clear ownership is defined from the outset, and the budget restrictions and allocation is also agreed and approved early doors. It then sort of negates, I suppose, the chance of that happening to an extent where it reduces the chances of something like that happening if the full considerations have been taken beforehand and you already have a solution or you already have a product or system in place, but you want to supplement it and add to it and take it up to the sort of the next level of performance, rather than it sort of, as you say, being an investment up front without actually knowing where the roadmap is going. It's best to always have it as part of the roadmap rather than the kickstarter of the roadmap as well.
Yeah. I mean, it's you can't engineer everything from scratch perfectly. You always have that element of having a few rugs that are too large. You've got to use the platforms that have been tested, but don't don't get too embedded in that one part of them. Yeah, don't always necessarily use machine learning if you can use conventional machine vision. There's a lot of
Mm,
benefits of doing that. Same kind of hardware platform, same kind of products, but
mm,
there are other ways of doing the software that have a lot of benefits if you don't want to train models a lot, or you want to find out something that humans can't annotate, or so
mm,
there's a lot of scope in what is now called, I think, AI.
mm,
That isn't
mm.
isn't the stuff that's kind of been packaged with all of these machine vision systems is a good example of that.
Fantastic.
So yeah.
Brilliant. Pierre, it's been fantastic having you on. Just want to say thank you so much for your time.
No,
I
thank
think
you,
we've
Alex.
we've really touched on quite a lot of topics there, and I think we've managed to sort of carry a wide array of discussion, but also it's sort of come back naturally, hasn't it, to that sort of those two key themes, ownership and integration. It's brought us right back to the start quite nicely. So
Yeah, indeed. Thanks, Alex. Really good to talk to you. And yeah, integration's our thing. So nice topic to choose.
fantastic. Thank you very much.
Okay, bye now.
Take care. Bye-bye.